Introduction. Arithmetic is the branch of mathematics in which we learn about numbers, their operations and properties. Geometry deals with shapes and lines, and algebra is the branch of mathematics which involves numbers and letters to represent variables. Let us learn about fundamental concepts of algebra. There are two types of symbols in algebra. A. Constants. A symbol having a fixed numerical value is called a constant. Thus, the number 4, -5, 7/5, 1000, etc. represent constants as they have fixed value. B. Variables or literals. A symbol which takes on various numerical values is called a variable or literal. Literal or variables are represented with small English letters, example, A, B, X, Y, etc. Numerical expressions. A combination of numbers connected by one or more of four basic operations, that is, plus, minus, multiply or divide, is called a numerical expression. Example, 4 plus 3 minus 2 multiplied by 3 divided by 3. Algebraic expressions. An expression which involves both constants and variables is called an algebraic expression. Example, x plus 5, 2r plus 3, or x minus 5 by 4, etc. are algebraic expressions. Matchstick patterns. Can you guess how many matchsticks are required to continue the pattern 9 times? A, B, C, D. Stage, number of matchsticks, pattern 1, 2, 1 multiplied by 2, 2, 4, 2 multiplied by 2, 3, 6, 3 multiplied by 2, n, 2n, 2n. Therefore, number of matchsticks required for continuing the pattern 9 times is 2 multiplied by 9, which is equal to 18. B. Stage, number of matchsticks, pattern 1, 2, 1 multiplied by 2, 2, 4, 2 multiplied by 2, 3, 6, 3 multiplied by 2, n, 2n, 2 multiplied by n. Therefore, number of matchsticks required for continuing the pattern 9 times is 2 multiplied by 9, which is equal to 18. C. Stage, number of matchsticks, pattern 1, 5, 2 plus 3 multiplied by 1, 2, 8, 2 plus 3 multiplied by 2, 3, 11, 2 plus 3 multiplied by 3, n, 2 plus 3 n, 2 plus 3 multiplied by n. Therefore, number of matchsticks required to continue the pattern 9 times is 2 plus 3 into 9, which is equal to 29. D. Stage, number of matchsticks, pattern 1, 4, 1 plus 3 multiplied by 1, 2, 7, 1 plus 3 multiplied by 2, 3, 10, 1 plus 3 multiplied by 3, n, 1 plus 3n, 1 plus 3 multiplied by n. Therefore, number of matchsticks required to continue the pattern 9 times is 1 plus 3 multiplied by 9, which is equal to 1 plus 27, which is equal to 28. Example 1. Mother has made laddus. She gives some laddus to guests and family members. Still, 5 laddus remain. If the number of laddus gave away is L, find how many laddus did she make. Let laddus given away is equal to L. Number of laddus left is equal to 5. Total laddus made is equal to laddus given away plus laddus left, which is equal to L plus 5. Example 2. Oranges are to be transferred from larger boxes into smaller boxes. When a large box is emptied, the oranges from it fill 2 smaller boxes and still 10 oranges remain outside. If the number of oranges in a small box are taken to be x, what is the number of oranges in the larger box? Let the number of oranges filled in a smaller box is equal to x. Therefore, the number of oranges filled in 2 smaller boxes, x plus x, is equal to 2x. Number of oranges left is equal to 10. So, total number of oranges in the larger box is equal to number of oranges in 2 smaller boxes plus 10, which is equal to 2x plus 10. Example 3. Look at the following patterns made up of matchsticks and write the pattern that gives the number of matchsticks in terms of number of the figure. A, B. A. 1, 4. 1 plus 3. 1 plus 3 multiplied by 1. 2, 7. 1 plus 6. 1 plus 3 multiplied by 2. 3, 10. 1 plus 9. 1 plus 3 multiplied by 3. N. 1 plus 3 multiplied by n. B. 1. 3. 1 plus 2. 1 plus 2 multiplied by 1. 2. 5. 1 plus 4. 1 plus 2 multiplied by 2. 3. 7. 1 plus 6. 1 plus 2 multiplied by 3. N. 1 plus 2 multiplied by n. Expressions with variables. Variables can take different values as they have no fixed value. Thus, all the 4 basic operations of addition, subtraction, multiplication and division can be performed the same way with variables as we do with numbers. The value of an algebraic expression like 4x plus 5, which contains the variables x, can only be calculated if the value of x is known. How expressions are formed? Using only letters and signs, we can write the expression for the statement given. Statement, expression. A. 4 added to x, 4 plus x. B. 7 subtracted from x, x minus 7. C. X subtracted from 4, 4 minus x. D. 2 subtracted from the sum of x and y, x plus y minus 2. E. 6 added to the product of x and y, 6 plus xy. F. Q multiplied by minus 5, minus 5q. G. 5 added to the product of 3 and y, 5 plus 3y. H. Product of 2 and x divided by 3, 2x divided by 3. I. N multiplied by 2 and 1 subtracted from the product, 2n minus 1. Similarly, we can write the statement of algebraic expressions as explained below. Expression, statement. A. 2z minus 4. 4 subtracted from the product of 2 and z. Or, first multiply 2 and z and then subtract 4 from the product. B. Y divided by 8. Number y divided by 8. C. 10y plus 7. Y multiplied by 10 and then add 7 to the product. Or 7 added to the product of 10 and y. D. 25 minus 2r. Product of 2 and r subtracted from 25. E. Z minus x plus y. Sum of x and y subtracted from z. F. Minus 9z. Minus 9 multiplied by z. G. 10a divided by 3. 10 multiplied with a and then divided by 3. Use of algebra in daily life situation. Let us see how we can use algebra in our daily life situation. Example 1. A bus travels at a speed v km per hour. It is going from Jaipur to Jodhpur. After travelling 5 hours, it was found that Jodhpur was still 20 kilometers away. What is the distance from Jaipur to Jodhpur? Solution. The bus has travelled for 5 hours. Speed of bus is equal to v km per hour. Distance travelled in 5 hours is equal to speed multiplied by time is equal to 5v km. Distance still to be covered is equal to 20 km. Thus, distance from Jaipur to Jodhpur is equal to 5v plus 20 km. Example 2. Change the following statements using expressions into statements in ordinary language. For example, given Salim scores R runs in a cricket match. Nalin scores R plus 15 runs. In ordinary language, Nalin scores 15 runs more than Salim. A. A notebook costs rupees P. A book costs rupees 3p. B. Tony puts Q marbles on the table. He has 8 Q marbles in his box. C. Our class has N students. The school has 20 N students. D. Jaggu is Z years old. His uncle is 4Z years old. And his aunt is 4Z minus 3 years old. Solution. A. Cost of a book is 3 times the cost of a notebook. B. Tony's box has 8 times marbles what he puts on the table. C. The school has 20 times the number of students in our class. D. Jaggu's uncle is 4 times as old as Jaggu and his aunt is 3 years less than his uncle's age. Equation. An algebraic expression containing the sign of equality forms an equation. Example, x plus 4 is equal to 7 is an equation. X plus 4 is to left-hand side of an equation and 7 is to right-hand side of the given equation. The value of x, which satisfies the condition for LHS is equal to RHS, is called the solution or root of the given equation. Is 4 multiplied by 5 minus 5 is equal to 15 an equation? Yes, but this type of equations are called as numerical equations as they involve no variable. To check if the value mentioned in the given column is a solution of given equation or not. Equation. Value of variable. Solution. Yes or no. A. 3x minus 5 is equal to 10. X is equal to 2. No. B. X plus 10 is equal to 15. X is equal to 5. Yes. C. P minus 3 is equal to 7. P is equal to 8. No. D. 2p plus 3 is equal to 15. P is equal to 7. No. E. 3x is equal to 21. X is equal to 7. Yes. F. T by 5 is equal to 4. T is equal to 25. No. G. 2L plus 3 is equal to 7. L is equal to 4. No. H. 2L plus 3 is equal to 7. L is equal to 2. Yes.